Hello everyone and welcome to this Tech Talk webinar. My name is Angelika and together with Bernhard.
Hello.
We are excited to have you here today. In this session we're going to show you an UltraMap demo with data captured from an UltraCam Merlin 5.0, and then Bernhard will going to highlight the latest features released in an UltraMap recently. Let's start with the UltraCam Merlin 5.0. It's one of our latest addition to the camera portfolio. It's based on Bayer pattern technology. It's a photogrammetric nadir aerial camera featuring the Sony IMX811 CMOS sensor. And the Merlin 5.0 features 37,500 pixels across the flight strip, distortion-free true nadir imagery, 3 exchangeable lens kits, a fast data capture at up to 1 frame every 0.7 seconds, and true pixel processing and adaptive motion compensation for sharp, crisp imagery. So the UltraCam Merlin is really built for scale and impact. All processing of UltraCam imagery happens within UltraMap, our photogrammetric software suite. UltraMap is purpose-built for processing UltraCam imagery and lets you produce, depending on the system you use, nadir imagery in RGB and colored infrared, oblique imagery, digital surface models, digital terrain models, imagery-based point clouds, ortho imagery, and 3D textured tints. Bernhard, today you're showing UltraCam Merlin 5.0 data processed with UltraMap 6.10. As mentioned before, the Merlin is based on Bayer pattern technology and delivers really high image quality, although the panchromatic-based systems are typically considered the absolute benchmark. What would you say about the image quality of the UltraCam Merlin, and how do we as Vexcel ensure that the Bayer data reaches its full potential?
So in addition to the hardware for capturing the data, it is very important to process the data in the best possible way. For processing biopattern imagery, we have optimized our TPP processing, the post-processing for raw image data, to handle these images with their characteristics in the best possible way. In that way, we can ensure that the image data coming from biopattern sensors, at least for our cameras, is very close to the level of pan-based image systems.
Mm-hmm. And one of the features that was recently introduced in UltraMap also contributes to the image quality of the Merlin, correct?
Yes, correct. So with the latest UltraMap version, we have released a new feature for GSD-based optimization of sharpening settings, for example. So that means the software is aware of the distance from the camera to the objects on the ground, therefore it is aware of the GSD, and then based on that knowledge, the software is then using predefined settings for sharpening and denoising and so on. Of course, these settings can be modified by the user if needed.
If you would like to see Merlin's sample data for yourself, we have both the full project and a small selection of stereo pairs on our website. You want to talk about this sample data that is available?
Yeah, so we have provided some samples from a data set that was captured in February this year. The data was captured in an area called Gleisdorf, a small town just east of Graz in Austria. The data was captured at a flight altitude of 1,600 meters above ground level, which results in a GSD of 5 centimeters with the lens of 90 millimeter focal length.
We'll put a link to the download area into the description. Bernhard, could you give the audience a brief overview of UltraMap and its capabilities?
Yeah, so UltraMap is our software for doing the full photogrammetric workflow. We have developed the UltraMap software in-house, so this is a Vexcel product, and it involves all processing steps ranging from handling the raw data as it is captured by the camera, then applying camera calibration, then preparing the block, doing error triangulation, radiometric adjustment of the images, including an automated color balancing, dense image matching, orthomosaic generation, and finally 3D models, so 3D meshes can also be generated.
So the data comes first into the raw data center.
Right.
Could you explain what happens there?
So UltraMap Raw Data Center is the tool on the one hand to transfer the raw data from data unit to some storage location, and then doing the processing from level 0, so that's the raw data stage, to level 2. In that processing step, camera calibration is applied to the data, so TPP is also being done, so that involves the correction of various characteristics of lenses, for example. Motion compensation is being applied, so that's the AMC, adaptive motion compensation, and a number of other processing steps and correction also done to the images. That generates then a flight mission file, which can be loaded directly into UltraMap Studio, and that then allows to visualize the data in a georeferenced way and therefore interact with the image block.
So the next logical step is then doing the AT, right?
So aero triangulation starts usually with first bringing in post-processed GPS data into the block. Then the type point collection is started. So that is the automated extraction of type points in between nadir images, and in case of an oblique camera, also in between nadir and oblique images. Then in the next step, ground control points can be measured. So this is optional. It is not required by the software, but usually projects always involve ground control points. For these measurements, we provide an editor that allows to measure the points in one image, maybe in 2 or 3 images, and then the software tries to automatically complete these measurements in all the other images to assist the operator. Then as soon as all these measurements are done, then a bundle adjustment can be processed. So that means GPS data, type points and ground control point measurements are all combined into one optimization. So the bundle adjustment can be done multiple times when changing parameters, changing measurements, and then all the results are summarized in a report. So this report gives all the statistics, all the numbers that are relevant to describe the results for this block. And then these results can also be visualized in the software in a 3D way. So for example, residuals for the GPS data, these can be displayed as well as residuals for GCPs. Of course, all of these data sets can be exported to some file formats to use in third-party software.
But we want the customers obviously to stay within our own workflow.
Yes, so we try to facilitate the workflow for our customers by ensuring that camera parameters and exterior orientation and all information that is required to set up the project is transferred automatically from one module in the workflow to the next, so there is no need to import or export any data and no need to manually set up any parameters.
One of the key features of UltraMap is our water handling approach. Bernhard, why is it even important to have a water handling strategy in the first place?
Yeah, water can be very challenging in the photogrammetric workflow. Water bodies can have very different colors and very different texture, and there can be reflections from the sun. So water can be an issue for creating orthomosaics. It can be very difficult to create a good surface model or terrain model including water bodies, because with just doing dense image matching there would be a lot of artifacts on the surface of the water. And third, if water bodies are included in the data, then this can increase dramatically the processing time, because on the water surface matches in between adjacent images are not that easy to do, so the software has to search a long time, therefore very high consumption of processing time.
And we found a way to speed that up. What is our approach? How do we handle water?
Yeah, we have invested a lot of development resources into finding a workflow that is really optimized for high throughput, high automation, but still maintains the good quality. So our approach is based on machine learning. So we do first a semantic image segmentation to identify all the water bodies. And this semantic image segmentation is taking benefit of our Vexcel data program. So we have a huge library of image data from all over the world with very, very different water bodies. All that was used to train the software to make sure that we can identify the water with very high reliability.
And where do customers find our water handling strategy within the workflow?
So within the workflow, we recommend that this is done right after the aerotriangulation step, because best possible exterior orientation for the images is then the best input for the water handling. So water handling itself, it involves processing a low-res DSM, then doing the semantic image segmentation, and deriving of height of water bodies, and later on moving on in the workflow. So following after that is then color balancing, then dense image matching, auto production, and so on. And in all of these steps, results and knowledge from this initial water handling stage is used.
So that's a great advantage for customers using the entire workflow. Could you show us something in UltraMap directly?
Sure. I'm happy to show you that with a brief overview. As our sample data for the Merlin 5 does not really include any big water bodies, I've prepared here a small data set captured with an Osprey 4.2 at the coast of Spain. So this is a data set that includes nadir and oblique images, and with this data set we can show nicely the workflow for the handling of the water bodies. The first step in this workflow is that a low-resolution DSM and a low-resolution ortho are created along with this water mask. So here in this DSM we still see all these artifacts from dense image matching, as the water bodies were not yet handled automatically here. So this is the first processing step where the user can already interact with the data, modifying the water mask, or the user could also bring in a water mask from an external source. Then in the next processing step, the software is automatically analyzing the height values at the coastline of the water, and then based on these height values it is automatically deriving the height of the water body. So here we see the water that is already very flat with this height for the water being derived automatically by the software. That can also be loaded into the editor to facilitate then quality control of this, and also modification of the height of water bodies if needed. So here in this corner we see that the water is a bit too low, and that can be modified in a quite easy way. So now the operator is looking for height values here along this beach. So these are height values that can be used to do the new water body height. And with this tool here, this value of 1.2 meter, which should be used for the water body, can be entered, and then the tool can be used to create a polygon, and all the water within this data set gets now this new value for the height of the water. So this polygon that is created by the user is intersected automatically with the water mask. So therefore at the coastline the user does not need to do a lot of clicks to describe the water body in an exact way. So now switching in between results of before and after, we see that after the edit it's a very nicely adjusted water body. And also in the main view we see now the data corrected.
Our customers fly typically very large projects over days or even weeks, so there are some atmospheric changes, the weather condition changes, the sun angle changes. This all has an impact on the image quality, and how do we ensure that the end product is balanced?
In our workflow we offer the color balancing. This is an automated approach to get rid of these differences from single input images and to make sure that input images and also single flight lines, different blocks, all that is well aligned and is then used to create a homogeneous block within the data set. So it's not making the colors nice. That is done in a step afterwards. But the color balancing, that is creating a homogeneous block. Let me show you the color balancing in this short overview here. So I've switched now to the Merlin dataset back from the previous Osprey dataset. And in this Merlin dataset, we see here that in the center there is a quite dark line. So there was some change obviously during the flight. And now we see the balanced result. So the automated color balancing, that is making this block homogeneous. So such dark lines can be adjusted to the bright lines. In the background, there are always the single images available. So from the overview ortho that we have seen earlier, we can always switch to the single images and then see the effect of the color balancing on the full resolution of the image data. Further adjustment of radiometry can be done on the entire block of images shown here in this low resolution ortho. So curve, gamma and levels adjustments, for example, can be done to this data.
The semantic segmentation is not only very helpful for water handling, but also in the next phase where we talk about dense image matching and ortho pipeline. Because we use it to create the DTM. Can you show us what happens in the next phase?
Sure. Here we see now an overview of this project area with the DSM being processed at high resolution for this central part of the project area. So that is now an overview of this DSM color-coded by elevation. Based on this DSM, the DSM-based orthophoto, a true orthophoto, can be created both in RGB and colored infrared in a synchronized way. Now we see the contribution mask to this DSM ortho. So every single color represents one input image for the ortho mosaic. So based on the DSM and using the semantic image segmentation, the software can automatically filter to the DTM. So all objects that are above surface are detected, so like buildings and trees and cars and so on, and they can then be removed automatically from the DSM. These objects are shown with that mask here. Semantic image segmentation is also used to detect bridges. So if the purpose of the DTM is to create a DTM-based orthophoto, then it makes sense to include the bridges as we have seen them here highlighted in yellow. And then based on the DTM, a DTM orthomosaic can be created automatically by the software. And the seam lines, as we see them here, they try to follow the roads and avoid buildings and so on to not create any artifacts in the mosaic.
The DSM and the DTM are produced automatically in UltraMap. What if there are any specific requirements to the DSM DTM? Is there any way to edit the data?
Yes, there is an editor in UltraMap that allows you to modify the data as needed. So starting with the overview of the DSM, the user can do quality control of the entire dataset at full resolution, and then if some issue is detected, then tiles can be selected and they can be loaded into the editor for visualization in 3D. So that is the DSM now at full resolution of the 5 cm GSD of the input images. So for example here we are doing an edit to get rid of some of the cars on this parking lot. So with this tool, this area is just smooth and these cars are gone. Another example for a modification of this dataset is with this snow here. So also this can be just described with this polygon, and then the area is smoothed and it's gone. And when switching back and forth here, we see the effect on the projection of the images when changing height values. Similar tools are also available for the DTM, and for the DTM we also have a special feature. So if you need a certain area from the DSM in the DTM, maybe some terrain changes, building, bridge, whatever, then you can use this ground tool to highlight the area in the DSM that you want to have in the DTM. And then using this smoothing tool, the transition from DTM to the imported DSM area can be smoothed, and then you have this seamless integration of height values in the DTM. And based on this modified DSM and DTM, reprocessing of the orthomosaics can be done in a fully automated way by the software.
Like for the DSM and the DTM, also the orthomosaics can be generated in an automated way. What editing options do I have in this orthomosaic creation?
UltraMap offers an editor to modify the seam lines. So the seam lines can be displayed for quality control, and then for selected areas the seam lines can be placed into other locations, and also different input images can be selected. The seam lines are placed automatically in UltraMap by doing a difference from DSM to DTM, therefore finding elevated objects, and then the seam lines try to always follow roads to avoid that any buildings are being destroyed. Here I would like to show a small example of this building block that is currently textured with image content from the green input image, and this should now be textured with the violet image. So first the polygon was created, the polygon started in the violet image, and then drawing this polygon around the object, then we saw automatically how the input, how the data is being changed for this polygon area. Also this preview here shows us the orthomosaic after the modification of the seam line.
The last step in the workflow is the 3D module that also got a major update last year with UltraMap release 6.6. The Merlin is a nadir camera, but can we still see Merlin data in 3D?
Yes, absolutely. So the 3D processing is not limited to only cameras that have nadir and oblique images like the Osprey and the Dragon, but this processing can also be done for data from nadir cameras only, so like the Merlin or the Eagle or our other nadir cameras. The 3D data can be processed either for the entire data set or just for a small selection within the project area. Here in our example, a small region in the center of this little city has been processed to 3D. This viewer shows us the 3D mesh that was generated automatically from the nadir images from the Merlin. The texturing was then also done automatically based on nadir images alone. The new version that was released last year includes improvements for processing performance, data structure, and also it adds additional output formats for the 3D data. And this here just shows how the data can also be visualized in alternative ways, showing all the single triangles color-coded by elevation or textured with all the information from the RGB images.
UltraMap version 6.10 was recently released and introduces an exciting new feature, which is the support for command line interface, which further reduces manual effort by automating processing steps. Bernhard, what are the key benefits of the command line interface and who is it designed for?
So this is a great new feature. It allows to interact with the workflow in a new way, not requiring the graphical user interface for a lot of steps. For Some steps like ground control point measurement, you still need to use the interface of UltraMap Studio, but a lot of other steps can be automated with this new tool for scripting. It is a new license feature, so it does require enabling this additional license to take benefit of the new command line interface. The tool allows you to automate a lot of steps in the processing workflow, and repetitive tasks can be done therefore in an easier way. Also, for example, exporting of the data in very different versions like RGB and colored infrared, 8-bit, 16-bit, all that can be automated by creating the script and using the new interface for doing these steps in a repeated way with just minor modifications. Let me show you a small example. Here in this dataset of the Merlin, I have selected a bundle adjustment result in the error triangulation stage. And I would like to do a very simple export operation, which is the exporting of exterior orientation. This can be done in the graphical user interface by selecting the export tool and just running it, or we can also automate. So now I just did create a template for doing this export. This template holds all the information for this export. All the parameters are stored in this single text file, in the small text file that we see here. On the left-hand side, I have now Windows PowerShell, and in Windows PowerShell I can call this executable that is required for operating the command line mode. Now just typing help here, that lists me all the very basic commands that are available. So there are commands ranging from submitting jobs to exporting data, and also some additional jobs. I'm now creating here a new job for exporting the exterior orientation. And just executing this command without any arguments, we get information on what are the arguments, the parameters for running this small job. I just add here the project path, so path to the project file where I want to export the data. Then I'm adding the workflow node ID. So now with this new tool, every single action within the UltraMap Studio has an ID. In this case here, the bundle adjustment has the ID, the unique identifier number 9. So the tool knows where to export the data from. And then the path to the template, so this is the small file where all the parameters are stored so that the software knows what it should do, how it should handle the export. And then I'm just running this command with all these actions, and then we wait for the result. So the export already finished, and this tool also gives then a message, in this case here, operation completed successfully. So that allows also to read automatically the success of any processing step, so that in case of any errors, some action could be taken. So this was just a very simple example to run one single task, one single export operation. This interface can be used to combine a lot of processing steps and export operations into a script. So in that way it allows them to automate very complex workflows. And for example, export operations can be facilitated by creating let's say one template for RGB images, and then using that template and just replacing RGB by colored infrared and RGBI, and therefore exporting a lot of variations of the data with very low additional effort.
I think this is really a great feature and will help professional processing environments increase the efficiency a lot. Another feature in the context of the raw data center is that we removed the admin rights for this raw data center. Why this change?
Yeah, so this is a small change, but we think it has a huge impact and brings great benefit to a lot of users. Because very often IT security policies in organizations are quite strict, and administrator rights are not that easy to grant to any users. There was a reason for why the raw data center required administrator rights. And that was a reason not because of the UltraMap software itself, it was rather because of the Windows operating system. So some features of Windows were required to do certain operations in the raw data center. We could find a way to run a lot of these operations now without the administrator rights. So that means standard operation can now be done with a default user account without admin rights. Some operations still require admin rights, but this is not the standard use case, I would say. So therefore, it's a great improvement that helps organizations to well maintain their IT security policies.
Also in regards to the IT environment, UltraMap with the latest version 6.10 now supports cost-effective GPUs. So customers can choose from a wider range of more affordable NVIDIA GPUs. Why would you recommend customers to invest in GPU technology?
Yeah, GPUs can provide a lot of benefit for the processing performance. Some processing operations can be accelerated by GPUs, and in UltraMap we are using that for the dense image matching at the moment. We are looking at other steps in the processing workflow to be accelerated with GPUs in the future. So it makes sense now to consider already GPUs if thinking about an investment in processing hardware. The new improvement that we have added recently, that allows to use consumer-grade GPUs. So we are not only limiting the GPUs now to data center GPUs, but also other GPUs from NVIDIA can now be used within UltraMap.
On our website, we also have an overview of all the major features that have been introduced in UltraMap version 6. Feel free to take a look at the website. We will put a link into the description. So Bernhard, after one release comes the next. Can you give the audience some peek on what's coming up in the next releases?
Yeah, we are working on a lot of improvements, and one improvement to be expected quite soon, that is for the color balancing. So we are aware that there are some challenges with the current implementation, and our goal is to improve that a lot to be able to create more robust results.
All right, that brings us to the end of this session. Bernhard, thanks for giving us such a great overview of the UltraMap workflow and for also showing that you can use the Merlin data throughout the entire workflow and all the modules.
Yeah, so the great system design of the Merlin and the features that we have implemented for ensuring that the data quality is of high level, that shows even for this sample data set that was captured in winter conditions with very low light, that the results are great and that we can achieve good data processing from the raw data until the final products.
And once again, if you want to take a look at the exact sample data that we showed during the webinar, go on the website and download a small sample or request access for the full project. Also on the website, you will find a blog post about the command line interface support to get some more information. And Bernhard, where do customers need to go if they want to learn something about the GPU support?
Yeah, we are very happy to assist with this question. So just reach out to our team and we will provide you a lot of information that you might find interesting.
Perfect. So I think now it's time for the Q&A. Feel free to post your questions and we are happy to answer them. Thank you.
Hey everybody, welcoming you to the Q&A session of this webinar. First question is, can you send a full workflow manual from data processing to also production with required input parameters at all processing steps? Bernhard, I would say that's a question for you, please.
Yeah, so the software does include a full manual, of course. So that is available with every installation of the UltraMap software. And if you don't have the UltraMap software, please reach out to us directly, to our support team or to your sales representative of your area. And then we can also provide you the information.
So next question is, the Merlin has only 2 RGB lenses. So how can you achieve such a big footprint with them? Yeah, that's a great question, and many of you might ask this. And the reason here is that between the two lenses, we have a total of 3 CMOS sensors. So one lens has a CMOS sensor exactly in the middle of the lens, but we have very special and custom made lenses. So the huge benefit of our lenses is they have a very large image circle, which is way bigger than the area of which is covered by one CMOS sensor. And this allows us to not only place the CMOS sensor in the center of the lens, like it is done when you have cheaper lens systems, we can also move the sensors to the side on both sides, and still it is all within this big image circle who provides utmost quality. And with that, we have this very specific setup of that there's one CMOS sensor in the center in one lens, and then we have the second lens, and this second lens has 2 CMOS sensors which are moved left and right. So they are covering the areas right and left of the image footprint, but this is all still done in a fully nadir-oriented lens without any tilt. So because of that, because of these unique lenses with a big image circle, we have this very specific and unique feature of the Merlin that we have two true nadir lenses with C3CDs behind, or 3 CMOS sensors behind, and that gives us this huge footprint of 37,500 pixels. All right, next question is, can the new command line feature work with data processed in older UltraMap versions? Bernhard, handing over that question to you.
Yes, so this new command line feature, the command line interface, that does not require that all data is processed with the latest UltraMap version. So also data sets that started processing in earlier software versions can take benefit of this new feature. So just upgrade to the latest version and you can use this automation with the command line feature. So the general rule is, as long as you can open an UltraMap project with your current UltraMap software version or with the latest software version, then also this command line feature can interact with that data.
Next question. Can I license only specific UltraMap modules depending on my workflow? The answer is yes, you can do, but this is a kind of a waterfall model. We have the modules in the chain, like the essentials, the AT, the dense matching, the also pipeline, the 3D module. And the modules are always building on top of each other. So when you want to use the dense matcher, you need to have essentials and AT and the dense matcher. You cannot use just the dense matcher because the dense matcher is using the data from the previous modules. So you can put your workflow together, and we have interfaces to export and import data. But this is a kind of a waterfall model where each module sits on top of the other. So when you want to have the last module, the 3D one, you need the full stack. When you want to have AT, you need essentials and AT and so on. When the release of new UltraMap updated with improved color balancing can be expected? Bernhard, can we already share, let's say, a rough release date for that?
Yeah, it's not yet that easy to give a release date, not a day, but we have a time frame in mind. So yeah, development is ongoing. We are working with prototypes and so on at the moment and running various tests. And it's looking very positive that we can offer a release beginning of summer. So that would be something like June, July. So I see now here a question, will the improved color balancing work with Mark III sensors? So yeah, the new color balancing will also work with imagery from the Mark III sensors. So there is no limitation of the new algorithms to just the latest generation of UltraCams. So it's a goal of our development to enable all the algorithms always for all camera models, all UltraCams that are out there. So the Mark III cameras, they will also benefit from this new algorithm.
Great, perfect, thank you. Another question, I cannot utilize GPU without the license. Yeah, this is correct. If you don't have a software license for the utilization of the GPU, you can't use it. So you need a specific GPU license to use them. Is command line interface support available only in UltraMap Studio? Bernhard, handing over the question to you, please.
The entire workflow in UltraMap Studio can be controlled with a new command line interface and also the raw data center. So that means the full workflow from handling the raw data, starting the processing to level 2, so generating flight missions, then bringing that into an UltraMap Studio and so on. All of that is fully supported by the command line interface.
Well, that's cool. That's really great news. So another question is already coming in. Is TTP available only for UltraCam Merlin or also for all other UltraCams? Bernhard, you want to take it or shall I do?
Feel free to start with that.
Yeah, okay. So the question is, the answer here is easy. It is available for all UltraCams, and TPP is finely adjusted to the respective model. So this is the strength of the whole UltraCam family of all the modern UltraCams. Could you also say something about AMC? AMC, this is the adaptive motion compensation. So that is our software-based solution to deal with any motion blur which can occur during aerial survey. Well, plane flies and planes sometimes fly in shaky environments, and although the ground is changing, valleys go down, hills come up. So a lot of things happening during an aerial survey. And that cannot all be compensated by the mount because the stabilized mount is reactive and not fast enough. So we have elements, different elements of motion blur in flight direction, but also across flight direction, and also rotatory elements, nonlinear rotatory elements. And that impacts the sharpness of the imagery negatively. And we have developed a software-based methodology called adaptive motion compensation, which corrects by later in the processing for all these motion blur elements which can happen during the flight. And that is true for all the nadir images, but also for the oblique images. So it is a complete solution which ensures sharp imagery under critical flying conditions. And that's totally unique to the industry, as UltraCam is the only software or the only camera system which corrects not only forward but also in many directions, rotatory elements, change of scale element, giving a full suite of compensation for everything which happens in the air. Do I need to buy UltraMap, or are there other models available? So now I'm not totally clear what is meant by models. I'm assuming that this refers to third-party software systems. If not, please clarify. So one software module is required to process UltraMap data, and this is the so-called UltraMap Essential module. Here are the camera-specific corrections like the stitching, the geometric corrections, the radiometric corrections are applied. And that sits on the proprietary file format of UltraCam, and that's a module you need. Then you have the choice either to continue in the UltraMap workflow, which is a highly integrated workflow, and all the modules are integrated into one user interface, works on one database, and so on. So you have a lot of benefits if you continue your processing in the UltraMap workflow, run your AT, in the AT module, run your dense matching, generate your DSM, DTM models in the dense matching module, use the UltraMap author pipeline for your author projection for DSM and DTM authors, and then jump into the 3D module for your 3D tin generation. So that's a whole and highly integrated, highly automated workflow we offer. But if you prefer to use third-party modules, we have interfaces to export the data in standard file formats so that you can use third-party software to complement the workflow. What CMOS sensors are you using in the Merlin? With UltraCam, we are currently standardizing on the Sony IMX811 sensor. That is the latest technology from Sony available for aerial cameras. Gives the biggest pixel amount in the industry, and we have moved the whole UltraCam family to this new sensor. Actually, we have a vast experience already with the sensor. The first model based on the 811 sensor has been launched in March 2025, the UltraCam Osprey 4.2. And since then, we are gaining experience with the sensor and have transformed the whole UltraCam family to this new sensor. Assuming the question is if it's possible to rent the UltraCams, yes, it's possible. We have the sensors to test it out. Or if you have a peak load where you need an additional camera, you can do this through a rental. However, the pool is not endless, and there are peak seasons in Europe, like now in spring, for example, or early spring. So if you need rental, ping us as early as you know. And just rounding this up, also for the UltraMap software, we offer several licensing options. We have the perpetual licensing for the software you want to own, but we have also a subscription module which you can use if you have a temporary need for peak processing, or if you have a project where you need a specific processing like author pipeline which you didn't own before. Then you can subscribe it for a month or 2 or 3 or 6 or 9 or 15, whatever the right number is for your project, and with that you have also flexible licensing on the software side. The author photo is generated automatically by the software, but is there ways to do it by the operator himself? Bernhard, I would love to hand this question over to you, please.
Yeah. So yeah, the author mosaic is generated automatically by the software. That means the software is finding where to place the seam lines in an automated way based on all the data that is available. That means based on DSM and DTM and also RGB and near infrared information. The operator can interact with the data, so the seam lines can be modified. Also, seam lines can be exported if needed. So there are some ways to interact with that.
Do you have plan to have your AI? So maybe Bernhard, do you have an idea how to answer in more detail? So my general answer will be UltraMap is already using AI-based technology, algorithms, methodology inside the software. One example is the generation of the water masks. There we are using AI-based models to find out what could be water in the imagery and to extract the boundaries of the water. So this is a big, heavy AI loaded software feature, and we were in the lucky situation that with the Vexcel data program a worldwide a database of imagery covering the whole world or huge parts of the world, and that database were used to train the AI algorithms in UltraCam and UltraMap, so that it can deal with water, how it looks like in the US, in Europe, in Australia, and so on. So short answer is yes, we are using AI-based algorithms inside UltraMap. Bernhard, anything you want to double click on? Yeah, please.
Yeah, maybe just adding to that. Yeah, on the one hand, we are using such technologies for image segmentation and classification. On the other hand, we are also using that in the step for going from the DSM to the DTM. So actually, in those areas where there is non-ground, so like tall buildings or buildings and trees and cars and so on, where we need to fill the height field with some information. That is also depending on some algorithms that take advantage of understanding the scene around that area that needs to be filled with height values.
So which industry benefits most from this solution? So I now need to guess a little bit. What does this solution mean? It's what we are doing with UltraCam and UltraMap. We are providing basic data sets like imagery, stereo imagery, surface models, terrain models, and also imagery. So they are not exactly tailored to serve the needs for a specific industry. They are basic data sets, and many industries, so every industry who needs imagery can grab these results and work with it on their specific applications. So I would consider what we are doing really a kind of providing basic data sets, imagery and 3D data and metadata information like the classifications, like the water masks, and all this can be ingested in many vertical applications where we are not specialized in. So our aim is to provide in the most efficient way the best possible basic data sets, and then it's on third-party software to provide industries applications. That's, I think, the best way I can answer this question in a generic way. I would say that that brings us to the end of this tech talk, and I would like to thank everybody on the line for attending. Hope you find it worthwhile spending your time with us, and I'm looking forward to meeting you again in a tech talk or webinar or in person. And also thanks a lot to Bernhard Schachinger and all the people behind the scenes to making that tech talk happen. Thank you.